everybody. Thanks, Katie. And like Katie said, welcome to our introduction to the MySQL Database Service. I'm Mark Leith, Software Development Director on the control plane side of the database service. Just a quick start off. As standard, safe harbor statement, some of the things that I might talk about in this webinar may not be actually ready yet. The bulk of it is ready where I talk about some things that aren't ready, I'll pull those in. So Oracle MySQL Database Service, or as we've started abbreviating it, MDS, 100% developed, managed, and supported by the MySQL team. What is that? What are we releasing now? It's a fully managed database service. So it's cloud native, built on Oracle's own cloud infrastructure. It's fully managed by us, so you get the connection endpoint that you connect to as with other cloud providers, a normal cloud database as a service. We manage all of the automated provisioning, patching, upgrades, backups. We provide an interface for you for shared configurations across fleets of MySQL instances. And it's all fully based on MySQL 8.0 Enterprise Edition. So if you have MySQL 8.0 on any of your on-premise installs, it's fully compatible with 8.0. As I said, it's natively integrated into OCI. So that means it's built on its next generation infrastructure. Security is built in at its core and its focus. And it's released with the full range of interfaces that OCI has by default. So all of the standard console, CLIs, SDKs. It's available in multiple regions, right? As of today, it's in Ashburn, Phoenix, London, Frankfurt, and Sao Paulo, and it's quickly expanding into others. And as I said, it's fully managed and developed and supported entirely by the MySQL team. So essentially, it's a wrapping around MySQL. So on the bottom right, you see the standard interface that for MySQL for a client connection. We connect to a MySQL Enterprise Cloud build. In this case, it's the same as Enterprise, but we just build it with Cloud version string. And then everything around it is the database service that we're building and releasing today. So it comes with a natively integrated console into OCI. You can list all of your resources, launch them, manage them from there. And then a set of SDK interfaces around the REST API that does all of the management of the database service itself. So if you code in Java, Python, Go, .NET is in the node. We also support Terraform and Ansible for DevOps tooling as well, so that you can launch and manage your databases with code as well if you need to. The basic architecture of the service itself, on the left-hand side, you see what would be your user tenancy. On the right-hand side, you see a quote internal tenancy, how we manage the service internally. In your normal stack, you will have a VCN, you will have some kind of compute that you will want to talk to a database in some way. I've just called it a virtual machine. It could be a Bastion, could be a client, it could be an app server, could be a reporting server, whatever that is. They get exposed on some subnet in the VCN. And then from our service perspective, you get what's shown as a MySQL DB system exposed into a subnet on your network. In reality, what that is a secondary network VNIC that we attach into your network, and we're managing the rest of the infrastructure for you from there. So within our own tenancy, we launch the compute, we set it all up for you, we launch a bunch of block volumes, and we configure all of those optimally. And then we configure all of the MySQL database software as you ask us to. You can provide your own configurations and hand it over to you to use. But from there, we then continue to manage the life cycle of the instance. So there's API interfaces for you to be able to stop, start, restart. We continually in the background run workflows to do things like upgrades and continually check the health of the instances and the like. And then we report that all back up to you. We are the ones that then tie into the other standard platform interfaces in OCI as well. So if you're used to OCI with some of the other services, you'll know that you can tag resources, you can go and audit interface, API interface interactions. They have standard monitoring, event services, and all of those kinds of things. So when you interact with our API, we in turn push those events in the standard way so that you can see how people are using your DB systems as well. And the health checking is the thing that is also the collection to share a set of standard metrics with you. So when we say it's 100% developed by the MySQL team, what do we mean by that? So it really does mean that the MySQL team that I know and love, I've been working with the team for 15 years now, are the ones that fully own this service. So it means the MySQL Server team have been doing a bunch of work to get us to the point where we can actually release a secure service in a cloud infrastructure. The control plane team, my team, are the ones that have been building the infrastructure, the API infrastructure, the operational infrastructure, so that we can do all of the launching and managing of the database service itself. The standard MySQL backup team, the ones that have done MySQL Enterprise backup and alike, have engineered the backup architecture of the service. We have the HA team who work on replication, group replication, and those kinds of things. They've been working on what's called replication channels, so inbound and outbound, and read-only or HA with group replication. Those are not ready yet. I said I'd call those out. They're things that they're working on at the moment, but they are fully involved in MySQL Database Service and making it succeed from the HA perspective. And then we have the middleware and clients team who own things like MySQL Shell and have been doing work to improve the experience, to get data into the service, to do things like migration and all of those kinds of things. So we're fully invested from the engineering team's perspective into the service itself and making sure that MySQL runs appropriately for you as a MySQL Database Center service user. And just a snapshot of some of the things that, for instance, the MySQL Server team themselves have had to do to get us to the point where we can actually release a MySQL Server to you to use and for us to manage it in a secure way. So there were certain things like set persist and cryptographically signed set statements were done so that we can interact with the server to do configuration rather than configuration files. And then system users, admin address and port, these things were done so that we can internally administer the server whilst giving you the ability to create and manage users and those kinds of things, but not to drop our administration user, essentially, so that you can't kill the administration side of the service. Similar bind to network namespaces, host names longer than 60 characters. These were things that were done so that we could bind into your network and for it to work properly. Many InnoDB improvements, error log improvements, the shell stuff that I've just talked about. These are things that have been worked on in 8.0 and actually been worked on for quite some time as we built layers to get us to the point where we are now. And 100% managed by the team. So we build it, we develop it. My team are the ones that actually are the ones that manage all of the control plane. We are the ones that deploy it. We've turned the engineering team into a true DevOps team now, essentially. So the entire MySQL org understands how to operate the service. They've been staffed and trained in how to do database service operations. They understand how to react to problems figure out what's going on in the system and work out what's, any problem that's might happen with the database service or the control plane and the like. It also means that because we control all of the infrastructure, we've built our development process into that as well. So every new build that we do with MySQL, so if we're coming and getting ready for new versions like 8.0.22 that's coming up, for example, we also build in QA into the database service. So we build and test every new version prior to releasing it, and our QA team verify that everything is working fine so that it will be fine to roll out directly into the service immediately. And that means that we do automatic upgrades across all of these minor versions. So when 8.0.22, for example, comes available later this year, we will be able to roll out that upgrade to all of your database systems quite as soon as they're available. You're able to set your own maintenance window within the week, and then when that period comes around, we'll upgrade all of your database systems. And there's no lag for any important security things, particularly around all of the CPU releases that come around. And what this basically does is it's exposed all of our engineers really to the problems that people have managing database servers out there on premise and in the cloud or wherever it is, essentially. Before, they quote just develop the database server, but now they're developing and managing and understand the operational problems of what it takes to actually deploy and manage these database systems continually. It's a great thing from the engineering perspective. And then 100% supported by the MySQL team. What that basically means is you get MySQL support for no additional cost whenever you launch any MySQL database service system. The support team, like I said, I joined 15 years ago, and I joined in MySQL support as a support engineer and worked my way through support management. And they are really the best support team for MySQL in the business. I can say that without a doubt. And they're there to help you with the MySQL database service systems as well, in the same way that they have been there for you on premise. They have a wealth of knowledge across all sorts of different areas with MySQL, but they are also, as with the engineering team, fully competent database service operators as well. We've trained the entire group essentially, and support are now integrated into the engineering team themselves. So we have a 24/7 team worldwide, not just support, but from the engineering teams and operators and on downwards. We're all there monitoring the system, making sure that it succeeds, and helping you with any of the problems that you might have. I mentioned that security and compliance is one of the things that OCI and the cloud infrastructure focus on. So what does that mean from our perspectives? First, it means we're natively integrated into OCI from the identity perspective. So we have a set of IAM permissions that are integrated with OCI that allow you to set very specifically what users can do against the MySQL API. So if you can set, for instance, only user Joe is able to launch instances and only user Katie is able to delete them, for example, or put it on groups and those kinds of things with OCI. One of the other things that we decided when we were developing MySQL Database Service was to not expose any public IP addresses. Every other cloud service out there provide a way to open an endpoint to your database onto the internet. And there's been many documented breaches because of this, and we decided not to do that. We don't think it's a good feature. So we will only ever provide a private IP address as the endpoint to you on your network. And if you wish to expose it to the public internet, there are ways to route it there, but we will not do it by default. Also, it's encrypted by default. So all of the block volumes and alike that we set up when we manage the service for you, everything's set up to be encrypted at rest. And we load up a set of plugins that we actually provide these by default in MySQL as well. But we load them up and we configure them in such a way that they require that any user that you create has a password that is strong enough for pretty much any compliance standard. So if it's something like PCI or something like that that you require, every password, it requires a certain length, a certain number of characters, and all of those kinds of things. There's no way around that. It's built in, and you will need to provide that. So it's essentially we're building the layers so that it's fully ready for any of your compliance needs on top of the use of our service as well. So when you come to the MySQL DB system page, if you're surfing around in the console, the first time you come to it, you'll see this page. You'll see some prerequisites that need to be there. You will need a network for us to launch into. There's a network wizard. Just walk through that. It will set up a basic VCN with both a public and a private network. If you don't have one, if you're just doing a trial, if you do have one, great, we'll just launch into it. You'll also need to set up the policies that I talked about. So in order to launch DB systems, we need to be able to look at some certain things, to list things so that you can actually select things when you go into them, and a set of policy that allows you to manage our actual infrastructure as well. I'll show an example of that. Sorry, I'm going to quick. Yeah, so here's the sample policy. This is what something that you'll need to create in order to use our service or to allow people to use our service. By default, when you get a new tenancy, you get an administrators group. So this is the easy policy sample. But the bulk of it there is the middle row, where it says allow group administrators to manage MySQL family and tenancy. And that essentially means you get the manage level of privileges, all privileges, for all of the resources in the MySQL family. And I'll talk about which resources we have. But that gives pretty much every privilege that anybody would need to launch in the entire tenancy to the administrators. When you've set up your VCN, VCNs are set up securely as well by default in OCI, and you have to set up how you want the subnets to interact with each other. So for instance, if you have a private and a public subnet, you would launch the databases on the private one, and you might have a public one where you have a Bastion or web APIs and those kinds of things. This is what you would have to set up. Just as an example, you set up an ingress rule from one subnet CIDR block to the other subnet that you're currently talking to. So in this case, it's basically allowing access from the 10.0.0.0/24 CIDR for both the 3306 and 33060 ports. MySQL Database Service comes with both the standard SQL port and the X plugin configured and enabled by default for you as well. So you get both the standard SQL and the NoSQL access with a database system by default. You can choose to not route things to 33060 if you want to, right? And it depends how you set up this access on how traffic is routed to your database system. Some of the policy examples that I talked about, just so people get an idea of the kinds of things that you can do. So you can either be very wide, so allow a group to manage everything in the entire tenancy, or with OCI, it has a tiered infrastructure so that you have a tenancy which has compartments, and you can set very specifically who does what in specific compartments. So top to bottom, you can allow all of the administrators to do anything in the tenancy, or just allow it in a specific compartment. Or for example, auditors need to read things, but they shouldn't manage things. So you can give an audit group the ability to list things very specifically if you want to. So there's a bunch of different ways that the IAM or the identity policy language allows you to set access to the server and systems itself. So I'd encourage you to read the docs on that one. There's many different ways that you can set up access. So MySQL configurations. These are the building blocks of, if you will, of launching a DB system. So I'll start with that. A configuration is essentially a stored set of system variable config that we store, and then you can apply against any DB system that you launch. We have a set of default configurations that are optimized to every shape that we support to launch a MySQL system on. So when you launch a DB system with MySQL, you set the VM shape that you'd like to launch it on. And because it has a certain set of resources, the configurations themselves tie themselves directly to the shapes as well. For instance, we very specifically configure things like the buffer pool size and how many buffer pool instances there are, and redo log sizes, and all of these kinds of things. They depend on how many or how much resource you have on the host itself. So we've come up with the most, what we think that are the best default options for each of the shapes that we support. And then you can take those default options and you can tweak them how you like. So you can toggle things like the standard auto commit and a whole other set of other variables, for example. So I have a bunch of slides, but I'm going to actually jump out of slides, and I'm going to jump over to a console to show these things instead. So when you come to a standard tenancy in OCI, this is the standard landing page. You have this list of things that you can interact with. Here's all the standard infrastructure. But down here now, you should start seeing this MySQL. And you can see a certain set of things here. So as I said, the configurations, they come by default. We have a set of built-in default configurations. And for each of those, we have a default set of configuration that we apply to the instances. For anything that we apply on top of the AO default values, we expose those here so that you can see exactly how we're configuring the instances. If you can see it through show variables anyway, but if you wanted to see exactly how we configure, you can take this and configure your systems on premise, and they can look exactly the same essentially. You can see whether they are either default configured or not by these flags here, whether it's user defined or not. And then you can see whether any DB system is actually using the configuration. So in this case, they're not. I think there is one here that is. For a custom configuration, this is one I created earlier. You can see just the variables that are user defined. And in this case, I've defined a SQL mode and an auto commit one and overridden it. To create a configuration, it's pretty easy, right? You select a compartment, everything sits in a compartment. So I'll keep it in my intro compartment. You give it a name. you tie it to a shape, like I said. So, well, in this case, we're going to configure it for an E22. It has 2 cores, 16 gig of RAM, essentially. And then you pick the set of variables that you'd like to change particularly. So every configuration, like I said at the start, every configuration builds upon the default config. So you don't have to tune things like InnoDB buffer pool size. We will set that to what we think the most appropriate one is, but then you can override a set of the extra config as well if you want to. So like I said, there was auto commit, you know, I mean, you might want to toggle that to off. And each of the, excuse me, each of the variables that we support understands the metadata for the actual thing that we're setting as well. So you can override all of your config here fairly easily. Set a couple. Just show the SQL mode one, just so you can see how it does understand everything appropriately. And off you go and create your config, and it's then ready to use by any other DB system that you want to launch. Similarly, it's fairly easy to delete them. You cannot delete one that has an associated DB system with it. That's one thing to say, but if you're not using a config anymore, then you can delete it. We have a little bit of protection in there so that you really do say that you want to delete it, and off it will go. So once you have the, the building blocks for a configuration tuned to however your application needs, you can then use one of those to launch a DB system itself. So to launch, or these are the DB systems that are actually in my NVS introduction compartment. You can see I have one running at the moment. I'm going to quickly launch one just to show how easy it is. So when you come up, you select a compartment. It selects the one that you're in, gives you a default name, but let's call it something else. And then you choose where to put it. So with OCI, it has multiple availability domains within certain regions. So you can either choose to put it in any one of those. And then it has multiple fault domains within those ADs, so that you can essentially co-locate your database systems and your application systems and whatever infrastructure that you need within the same physical area, essentially within a data center. So you choose where you want to launch the thing. In this case, we'll put it in both of 3. You choose the configuration or the shape. So let's go with a 2.2. We don't show a configuration option by default. You can use the default config, right, for the most part, but if you want to use and override your config, we select that one. Set how much storage you'd like. I'd like a bit more. You get the chance to override your maintenance window. We will assign one by default, and it will just put it across the week or spread it across the week from our control plane's perspective. If you want it to happen on the weekend at a certain time, then you'd set that here. You have to define a username and password. This is essentially the root-like user that we hand over to you so that you can do things. And this is I mentioned earlier the password requirements. This is what we require for both the admin user, but also for every user that you create in MySQL Database Service as well. As I mentioned, this is compliance standard passwords, and it's a good idea to enforce those. So we provide one. We don't give any defaults for those. They should match. Okay. And then you specify where in the network that you want the database service endpoint to be exposed, essentially. So I've created a network earlier. I used the VCN wizard in my test tenancy. It creates a private subnet. It does have two, but in my case, we default to the private ones. You can give it a host name. And then you can actually change the ports if you wish that we expose the endpoints onto. These are what we bind the normal address and the X address to, essentially the X coding address. So if you wish to change those, you can. And then you finally configure the automatic backup schedules. The standard is to run them every 24 hours and to keep the last 7 days worth of backups. You can push that up to 35 days for automatic backups as well, and change the backup window if you want, but let's just keep that default. And that's pretty much it. From there, we'll go off and we'll create the database system as you've told us to. So off we go. We're trying to set up the DB system and do everything and configure it as you've told us to. But let's go and look at the one. Here's one that I launched earlier again. This is one that's been up for a couple of days. I think, yeah, it was created a day yesterday morning. And it was just created yesterday so that I could show an example of an automatic backup so that you can see that as well. But this is what you see when you go and look at the details of a DB system. You can see the OSID of the thing. This is the thing that you use to interact with it from an API perspective. If you're using a console or sorry, the CLI or an SDK or something like that, the OSID is important. It's the identifier for the DB system. And then you see the version, you know, the shape, the configuration, how you configured it when you launched it, the maintenance window that you were given. You can update those things as well if you wish. And essentially, excuse me, where it's exposed and how you talk to it from this perspective at the top level. When I showed you the examples at the start and the architecture, I talked about the metrics and us integrating with metrics. So these are the public metrics that we expose. It's been up for 24 hours, so let's have a look over 24 hours. They are the standard KPIs, right? So how many connections you have, how many active connections you have. So what's the concurrency on the database system? What's the throughput? What's the latency of all of those in milliseconds or the average latency? What's the resource utilization of the actual system that's been launched for you, and how, you know, the disk and IO are acting. IO is scalable as it is with block volumes in OCI by default as well. So the more IO that you allocate for your DB systems, the more IOPS that you can have for the database throughput, essentially. But you can see exactly how they're being used from all of the public metrics. The endpoints is essentially where we list how you connect to the DB system. At the moment, there's only one, but the plan is to add to that as we expand the various features that I was talking about from the replication perspective earlier. So as we add in things like read replicas and HA and alike, you'll start to see different endpoints that show up here that have different modes as well. And, you know, each one of those will be exposed here along with its status so that you can see exactly what the full picture of the DB system is. And that's really one of the key things from the MySQL Database Service perspective. A DB system is the logical regional abstraction of your MySQL database. So it's actually a regional resource in OCI, and it will span all of the ADs. And in the future, for instance, where you have, for instance, an HA system, where you set the AD here, you can imagine it will be spread across different ADs, and you'll start to see different endpoints and things like that that show up that make up the topology. So, you know, the DB system is the logical representation of the MySQL database system topology that your application talks to. Essentially, that's how you can think about it. From there, we also have backups too, associated with the DB system, so you can get to them very quickly from this perspective. They're listed both from the full list perspective or from the DB system as well. So you can see all of the backups that are happening and make sure that they're being taken okay, and you know the state's okay and alike. And from there you can quickly restore those things to a new DB system if you need to recover some backup. This one, you can see they're slightly different formatted. By default, when you take a manual backup, so I can, if I want to take a snapshot of a DB system for some reason, I can take a manual backup very quickly and easily. I can say I only want to keep it for 60 days and take a full backup, and off it will go. We'll take a backup of the DB system. Underneath the covers, it's essentially taking a set of block volume snapshots, very quick locking, or actually, sorry, no locking on the DB system itself. When we recover it, we just recover the DB instance, essentially. That's the same whether it is an automatic backup or a manual backup. In either case, we'll just take a block volume group snapshot and store it away for you. And then whenever your retention period comes up, then we'll automatically remove it for you in the background as well. So, as I said, you know, you can see every single backup that's happening in the system. Let's show just very quickly what it takes to restore one. So to restore, it's much like you saw with a create, essentially, right? But we take a bunch of the info that we already knew about the DB system. So in this case, it was in AD2 and fault domain 3, and it was this name. We give some extra, you know, description about where it was cloned from in this case, but everything else is pretty much the same, right? So you can take that. You do have to provide, at the moment, the same username and password, no different one. And then it tries to put it in the exact same place that it was launched. And again, with the same backup configuration, and off you go and create it. So, oh, sorry, if you have another host with the same name, you will need to give it another host name because you can't have two of those. Yay, live demos. Oh, yay, even more live demos. So I've reached my limits, and this is one of the things that you might see as well, just to, it's good enough to show you these things. We integrate with OCI and limits as well. So when you get the database service, if you're a customer, you get one of each of the shapes by default in every AD. If you go over those, you'll get one of these errors. And you'll have to choose either another AD. So in this case, I can go over to maybe AD3 and try it. Or you can ask for a limit increase. And that's got a standard way to do that through OCI. You ask us for an increase and we'll give you extra limits and off you go. So here you see, you know, you can, that also actually exposes one of the other things that I can maybe talk about as well, which is backups are also regional resources. So from AD1, if you have a DB system and you're taking backups in there, let's say the AD disappears and you need to recover it to a different AD, it happens, right? Data centers have problems. Because backups are underneath the covers a regional resource, we can quickly recover those into any AD that is within the region as well. So if AD2 goes away, like as an example here, then you can restore the DB system into AD3 and try and get it running as quickly as possible. Ultimately, when HA comes as well, we'll have that across all of them, but the choice is there. If you just run single DB systems and don't need HA and alike, then you can have the option of restoring these things anyway. So that's the bulk of the basics of DB systems, right? So you can launch, create DB systems very easily. You can take backups easily. They take them automatically. We have these shared configurations that easily manage and share across all of the DB systems that you launch. I'm not going to talk about channels here. There are upcoming webinars that you should also attend that talk about some of the other details about the MySQL Database Service. The one coming up in a few days talks about how to import and migrate, and that will talk about channels. Channels are not yet fully GA, so I will call that out. They are in LA, and if you'd like access to that, then talk to your normal channel and we'll see if we can. So to jump around a bit, I've talked about all of the database systems, and I've talked about backups. Finally, how do you connect to something in the database service? So one of the things to call out is all of the VMs that we launch in MySQL Database Service or in OCI, sorry, are based on the standard Oracle Linux VMs, which are RHEL compliant and don't include MySQL 8.0 client libraries. So if you want to launch something like a VM in OCI and start talking to a database system that you launch directly, across the shared network that I showed an example of earlier, then you'll need to actually install the community release Young repo and then install the client libraries from there. It's these three simple commands. From there, you take the DB system endpoint info that I showed in the console, or you can get it from the CLI or the other SDKs and alike, or all of the interfaces expose this. And you plug that into whatever connection that you're making to the database service, whether it be from a CLI, a shell, or an SDK or anything like that. Take those and plug it in. So this is the example of launching a compute, and I'll just instead show real details again. So I have a virtual network, like I said. It's got these private and public subnets. So my DB systems are launched in the private subnet. And then we have this public subnet as well, where you can actually launch computes that have public IPs and those kinds of things. So I've launched an example compute in my own compartment. It's this MDS client one. It has this IP address. Yay, it actually connects. And these are essentially the commands that you would have to run, right? So I've already run all of those on my compute. And from there, you can just essentially use MySQL shell, plug in your endpoint, and talk to the DB system, hopefully. Hey, so it's at least connected. And yay. So it's responding to us. So this is a MySQL DB system. It's exposed in the same way. Your standard interface is the same as any other MySQL server. You are slightly restricted on the set of permissions that you have. So just to show it. Oh. Really? Oh. Helps to type the right thing. Oh, geez. Right. So on actual MySQL global privileges, there are a set of things that you get. You can create things, you can do all normal DML. There are certain things that you don't get. You don't get some of the normal privileges that you might get on an on-prem system. So those are the things to be aware of. You also get a set of restrictions as well that get applied. This is something, again, that the MySQL server team implemented for us so that we could have users that aren't allowed to do things like drop or do DML on the MySQL schema, right? So you can't do something like drop the MySQL.user, right? You're not allowed to do all of those kinds of things, but you have otherwise an unrestricted ability to create users, grant on those privileges and alike, and create tables and all of those kinds of things. We just remove the privileges that might cause problems for the service management itself. Things like file, right? You don't place where things are because we're managing that for you from the system's perspective. But there you go. That's how you connect and use a database system in MySQL Database Service. So just to swap back, you get all of that in the database service in OCI at significant savings to any of the other cloud providers. We really are the most affordable. I mean, it's between 3.1 and 3.7 times less expensive at the moment compared to the other three major cloud providers to launch and use our service. And it's price and performance competitive as well. This is just an example based on 100 OCPUs, so some number of instances and a terabyte of storage used across all of those OCPUs in some way, and just cost it out for each of the regions for the, each of the US regions for the other cloud providers, and essentially for all regions in our case. And that is one other thing to call out. We don't change the cost of the service depending on which region that we launch it into. The cost of the service will be the same across every region, and it will be consistently and is consistently cheaper than the other cloud providers in every region. So there's a lot of good reasons to come and look at the service and use the service. And just in summary, to wrap that up, as I said, we're proud and excited to announce MySQL Database Service to the world. It's something that we've been working on for a long time as a team. It's something that for us in the MySQL group, we feel is important from our perspective to own a service that delivers MySQL to the world in a cloud perspective. 100% developed, managed, and supported by us. It's opened up the virtuous circle of DevOps to us as well. It's been a great experience to transform our group into a team that can deliver a service like this to you. So give it a try. It's easy to deploy. It's easy to manage. It will save you a bunch of cash if you're using some of the other cloud providers. It's ready to test drive in a region near you at the moment, and rolling out, like I said, to other regions. So if you start using it and you want to get in touch with us, you can get in touch with us through support. Like I said, if you want to talk to us through the normal social media channels, then get in touch with us through this. We have a developer live day happening on October 13th. If you want to come and learn more about both the database service, but not just that, all of the other innovation that the MySQL group has been doing as well. The group's been doing amazing work, then come and over, listen to it on the developer live day on October 13th. And like I mentioned, there's a set of webinars that are happening over the coming days that will talk you through some of the other details of the database service itself. I've given you a very high level picture of how to launch and configure and back up and recover them, but then how do you use them? How do you deploy? How do you manage? All of those things will be touched on in later webinars. So please come along to all of those, register, and come and learn a bit more about our service. And finally, test drive it. Like I said, Oracle are giving trials for all of the OCI tenancies at the moment. You can try it out for free. You get $300 worth of credits, which is quite not bad for if you just use a MySQL DB system and a single compute. That will take you some way for a while. So yeah, give it a try and get in touch with us and start using it.